Yeah, there are basically two topics for today. One is called method binding. Excuse me. Method binding, which is again one of these other fancy names, but does have some implications. And the other, which is going to be a little more germane to what we're going to be doing, has to do with abstract methods and classes. So what's this about? Well, first of all, method binding has to do with when the programmer, in this case, the Java virtual machine, when it determines what code to associate with a method call. So this is more of an issue with compiled languages than with interpreted languages. With interpreted languages like JavaScript, the basically the interpreter simply executes each line of code, kind of one at a time. That's the interpreter part. In compiled languages, the whole thing is compiled ahead of time, and the advantage of that is that the any syntax errors are picked up by the compiler. So there's a whole class of errors which you will encounter when running a scripting program, or could encounter, that you will not encounter in in a compiled program. Now, in the early days, the compile there were actually kind of two steps. One was compiling the code, and then the other was so-called linking the code. Again, you don't have to understand that so much, but as much as just understand that basically as early as possible, the uh, the compiler slash linker figures out what methods are going to be called by whom and where. In a dynamic language like Java, so despite being compiled, it's actually dynamic in many ways that earlier languages weren't. Um, this this is used for static and final method. The thing about, remember, with static methods, there's only one of them. So uh, so especially for a static final method, you can figure everything out about that ahead of time. Likewise, a final method is going to it's just going to be there. The problem is as we've seen, because of overriding and because of subclassing, um, the compiler and linker can't figure out at that time, until you run the program, exactly which method is going to be called by whom. Again, that's for non-static and non-final methods. So that's called late binding, and that occurs at runtime. So for non-final instance methods, it's not until it's actually run the program that it has to kind of figure that out. So in a way, it acts more like the interpreter in JavaScript or Python than the earlier static methods. So that's just something to kind of understand how the Java virtual machine is doing business, and that especially comes in when we talk about abstract methods. So the idea here is that you can declare a method to be abstract, and you might be thinking, okay, why would we do that? Um, well, just hold on. So an abstract method, it only specifies its name, signature, and return type. So there's no code associated with it. It's saying it's abstract. But the idea is that you're saying that some subclass of this is going to actually implement this method. The existence of the subclass of the abstract method in the superclass guarantees that the subclass, that an instance of the subclass, even if it's only defined to be a type of the superclass can be can pass the compiler basically. So we'll kind of see how that works. And the compiler is very OCD about this. So in other words, the idea is that when you specify an abstract method, you're saying this is going to be part of the interface for subclasses of this, but I don't want to I don't want to implement it yet. Why? Because it's going to be implemented specially by the subclasses, and we actually seen an example of this, and we'll show this when I illustrate it. So, in order to instantiate an object of the where the type is declared to be this abstract class, or the class with the abstract method, you can declare it as a type, but you can't instantiate it as a class. You have to override it in a subclass. In other words, all abstract methods have to be actually implemented in order to instantiate. So this is where that late binding idea comes in. So if I declare a variable to be an object of type of this class type that has an abstract method in it, the compiler will let me call it because syntactically it will work, but it won't execute it until it's actually implemented. So here's how you declare them. You declare it with this like this. So here's an example. Again, same modifiers. Typically, in almost all cases, we're going to have public methods. Again, that's not a strict rule like for instance variables, but you add this keyword abstract. So abstract says, okay, I'm going to define what this method is in terms of its name. So we have name, we have return type, and we have signature. So those are the three things that define a method's interface, together with the public, of course. So in the UML diagram, that's identified by an italic font. So if you see something, a method with an italic font in the UML, that's just going to mean that it's going to be an abstract method. So there's a related concept called an abstract class. So an abstract class, if a class has at least one abstract method, then the class itself has to be declared abstract. Meaning, what is abstract versus concrete? Concrete is something that's actually a thing. So a non-abstract class, which is everything we've been dealing with so far, a concrete class can be instantiated. Abstracting, what does abstract mean? Abstract is just sort of amorphous. Abstract is kind of conceptual, but not quite as real as something that's concrete. So I mean, in Java terms, abstract means a class which cannot be instantiated, which is declared to be abstract. So a class that contains one or more abstract methods must be declared to be abstract. Why? Because that signifies that class, an instance of that class, that is a variable that's defined to be of that class, cannot be instantiated. That is, I can't say new one of these classes. I have to subclass it and override all of the abstract methods. So I can't instantiate that class with new, even though I can define a constructor, but I can't use it. But it can be used as a data type. That's kind of the key. I can use it as a data type. And the UML diagram, that's identified by a bold italic font. So the names, and here's an example of this. So we're going to rework the example from yesterday. So if you remember, there was this method called play, and if you may have noticed that it was defined in instrument, but there was nothing in it. And in fact, each of the subclasses defined their own version of it. Why was this? Well, just to kind of loosely associate these classes with what they're trying to represent. If I say, oh, I have an instrument, and now I'm going to play this note on that instrument. What does it sound like? Well, in this case, that instrument can be any one of these four specific instruments. And, if you think of the difference between the physical instruments, if I play a violin, it's not going to sound the same as if I play the same note on a French horn or a trumpet or even a cello. So in other words, the loose concept here is that if I say all I know is I have an instrument, and so I want to write code that implements this idea that I'm going to play a note. If all I have is this instrument, then I don't know how to do that. Because I don't know what it's going to sound like. It's going to sound different depending on what concrete instrument it is. Okay, so what we're going to do is we're going to modify this example. And again, the book also has a similar kind of example, and just because I'm a bit OCD myself about this, I wanted to present it slightly differently, but that's, both are useful to look at. I mean, this is not, how should I say, what's useful is to look at both the way I'm doing it and the way the book is doing it are two ways of doing a very similar thing. And what that should tell you is that there's not necessarily only one right way to do it. So I'm not saying that my way is right and the book is wrong, or the book is right and I'm wrong. They're both right in their own ways, and they're both approaches to doing doing things. What the difference is that the type, in showing you it this way, the type is implemented by this enum, this family enum, whereas in the book's example, the type is, you see the similar things, string, there should be a T in there. Strings, there's strings, brass, woodwinds, and percussion were all subclasses of instrument. And that's another way of doing it. So in other words, you kind of have your choice, because the class can tell you about the type. The difference is here, if I go all the way down to the specific instrument, that to me was a little bit more concrete. Again, there's absolutely nothing wrong with the way that the book was doing it. So again, this is the same example as yesterday, only now we're going to take our instrument and we're going to make that play method abstract and show what the consequences of that are. All right, so here we are. And remember, what we had yesterday was, again, we were defining these as instruments so that we can put them all in the same array. See, if I had an array of trumpets, an array of violins, an array of French horns, an array, I would have to have 3 different arrays, because an array can only contain one type of thing. By making it the superclass, I can now put them all into the same thing, and now I'm free to use whatever methods are available in the instrument class. But if you will notice that Let's try to play, we didn't do this, let's try to play a note. So let's just have everybody play an A440. And when we run it, so we see that the trumpet is plying. It should be playing, of course. Oops. Try that again. As you can see, as I've mentioned, I'm subject to fat fingers myself. But now notice this though, is that if I define an I can define what are you doing? So I can define an instrument. Now I have to tell it what kind it is, but if I try to play it, then I don't get anything. See, there was nothing there. Right, why was that? Because when we look at the play method, there was nothing because we couldn't put anything there. Okay, so instead, what we're going to now do is make this abstract. So here's how we make it abstract. We say, come on. Now, okay, so if I say abstract, notice what it's telling me. It's telling me abstract methods cannot have a body. So no body, just a semicolon. Okay, so therefore, now notice we have another red squiggly here. We say instrument is not abstract and does not override an abstract method play. So what does it suggest that I do? It says make it abstract, and that's what we'll do. So now instrument must be made abstract because this play method is abstract. And so now I can't, I get another, this instrument is abstract and cannot be instantiated. So let's just sort of comment that just as a note. But now notice that I do not get red squigglies here. So let's instead of tuning, let's just sort of play this note. So not only are there no red squigglies, but they still work. They work fine. Why? Because each of them, and it's important to understand this. First of all, I can declare an array of type instrument, even though it's abstract. However, I must instantiate it with a concrete class. So each of these objects works because, in this case, say the trumpet implements this abstract method. And so does the violin, and so does the French horn. And so the thing is this, is that when at compile time, believe it or not, at compile time, it doesn't know what's going to happen. It doesn't know which method is going to be implemented when you hit this play. Because first of all, it's abstract. So it's not going to be the one in, it's not going to be the one in instrument. It can't be because there's nothing there. So this is what the late binding is about. It's not until, say, when it goes through these, when it hits the first one, and it's a trumpet. And it goes to the trumpet and then says, okay, it will bind this method to execute this statement the first time. The second time, it will bind to a violin and play this one, etc.
If you have a
it doesn't know this at the compile time. Was there a question?
Yeah, if you have a abstract method, does it require you to have a method inside each of the subclasses with that name to override it?
Great. Well, great question. Yes and no. The yes part is in order to instantiate, in order to be able to instantiate it, it must be. However, I can, let's, oh, okay, so here I declare I'm extending instrument, and if I decide not to override it, I can declare it to be abstract. Now it's still going to complain about the constructor business. So I still have to. Okay, my internet crapped out there for a second. What was I saying when when it crapped out? I was answering a question.
You were answering about overriding if the subclasses also needed to be referencing the abstract as well.
Right. Okay. Yeah. Okay. So here I've subclassed instrument, but I have not overridden the method, the play method. Again, I can subclass an abstract class, and in this case, I decided not to override the play method, and in that case, I must declare it to be abstract. So the answer is yes. You can override. You can extend an abstract class and not override all of the abstract methods. If you don't, then you have to declare that class to be abstract. Okay, so the ones that did implement it, like violin, did override the method. And here's one that didn't, and so I had to declare this to be abstract. So what that means is I can't instantiate one of these guys until I subclass it again. And let's see, that's not a terribly good. I'm gonna, rather than calling this a wood, let me just call this a.
Is there like a big purpose for that, or is that just kind of something you can do that we don't really need to worry about?
Well, the purpose is that sometimes I may have an abstract superclass that has a number of abstract methods, and I may have some subclasses. Again, in my design, I may have some subclasses where I can implement some, but not all of them. And so what I'll generally do with that is I'll have I'll implement some of them in the in an immediate subclass, and but they have to be abstract too. And then I'll subclass those, and then implement all the rest of them. Or you can continue that as long as you know, as deep as you want. But the main purpose is that I mean, in this particular case, there were some there can be some methods that you can implement. So in this case, the tune method was something that, just being a generic instrument, I can just use. But the play method is something that I needed to declare abstract, or I decided I wanted to declare it abstract. And so it had to be overridden. If there could have been other methods that I decided every instrument should have, but maybe the particular subclass didn't. The book actually has a better example of that, because then the book calls it for example, it would call it subclass brass, but under brass you would have specific brass instruments. You have trumpets and trombones and French horns and other things. So there the class hierarchy would go deeper, and so the continuing the book's example, you might have declared the brass subclass to be abstract and implement all the things that all the brass instruments have in common, but there would still be specific things that a particular brass instrument would not have. So that's kind of the why. I do want to show you the sometimes you name things and they're not the best name. I looked at this and I kind of did this off the top of my head. Woodblock is actually a particular specific percussion, but so I want to rename this. Now this refactor capability in NetBeans is actually kind of nice. So if I want to change the name of a class, it's actually a bit of a pain, because that class is going to be in a number of different places. So what I can do is I can right click and choose refactor rename, and I'm going to call this just sort of a generic percussion. And then notice what it does is it not only changed the name, it changed the constructor, and it also changed the name of the actual file that it's in. Okay, so why might I do this? Well, one reason is that because percussion instruments, you have things like the snare drum, the woodblock, and you have cymbals and timpani, and a piano is technically a percussion. So percussion is a lot more specialized and varied than some of the others. Like every string instrument has, in the orchestra at least, is in the violin family, or the viol family in the case of the bass. But basically they have strings and bows, and you can bow them or pluck them. Every brass instrument has the same kind of mouthpiece of various sizes, so you kind of blow into it in a particular way. The woodwinds are a little bit more varied. You have reed instruments like oboes and clarinets, and then you have things like flutes where they don't have reeds, but they're still all of a more similar type than percussion. So this is a reason why you might want to have an abstract percussion, generic percussion method, and then have additional subclasses of that. Okay, so let's see, no, I didn't have that here. Okay, so that's actually what I had for today.